Okay, factoring review. First thing we're going to do is talk about when a polynomial has terms in common throughout the whole thing. Like in these problems, all of these can be divided by 5 and x. So what I'm going to do is factor out a 5x. Parentheses is going to be what I have left over. If I take 15x cubed and divide it by 5x, left over I'm going to have 3x squared plus 5x squared divided by 5x is going to leave me with x minus negative 25x divided by 5x is just going to leave me with a negative 5. Double check your work if you are unsure about your factoring and multiplying back in. Okay, if I distribute this 5x back in, I'm going to get 15x cubed plus 5x squared minus 25x. If that matches your original polynomial that you started with, then you have factored it correctly. Difference of squares is a special rule. This is when you are taking something that is a perfect square and subtracting another perfect square. Factors in this fashion. For example, what do I have to square to get x squared? Well, that's x. What do I have to square to get 9? And that's going to be 3. So this factors into x plus 3 and x minus 3. If I factor the second one, see if you can factor it yourself first. In this case, what am I squaring to get 9x squared? Well, I've got to square 3 to get 9 and x to get x squared. What do I square to get 16? 4. So 3x plus 4, 3x minus 4. When you are factoring a quadratic where your leading coefficient is 1, you are looking for factors of c that add up to b. So that's factors of c that add up to b. So I'm looking for factors of 68 that add up to negative 21. So how can I get 68? Well, for starters, I can do 2 and 34. That's not going to get me anywhere near 21. So it's not divisible by 3. Maybe it's divisible by 4. 4 and 17. That's going to get me to 21. How? Well, they're both going to have to be negative, and it still multiplies to give me a positive. So x minus 4 and x minus 17. You can still always double check by distributing. So I'm going to have x squared minus 17x minus 4x plus 68. Does indeed give me my original when I combine my like terms in the middle. Okay, on your second one, try it. Come back and check. I'm looking for factors of 48 that add up to 13. So I'm going to start 2 and 24. Not going to cut it. It's not divisible by 3. Oh, it is divisible by 3. So 3 and 16, and that's actually what I needed. How do I get a positive 13? Well, 16 is going to have to be positive. 3 is going to have to be negative. That does multiply to give me a negative 48. So x minus 3, x plus 16. Okay, factoring when the leading coefficient is not 1. This is a little bit more complicated. We're going to start with the grouping method. You're going to start by multiplying your leading coefficient by your constant. That's going to give me negative 72. And now we need to find a way of rewriting the middle term, which is negative 1, as a factor of negative 72. So same thing, how can I get negative 72? What can I multiply? That's going to add up to negative 12. So 72 is 2 and 36. That's not going to work. What about 3? 3 and 24, not going to work. 4 and 18, close but not quite. It's not divisible by 5, maybe by 6. 6 and 12, not quite. 72 divided by 7 is not going to work. 8, 8 and 9. Okay, so 8 and 9 are going to be my numbers. Now, how do I need my signs if I need them to add up to a -1? Well, the 9's going to have to be negative and the 8's going to have to be positive. So I'm going to rewrite this as 6x squared plus 8x minus 9x minus 12. And then I look at my two groups. What do the first group have in common? They have a 2x in common, so take that out. Would have a 3x plus 4. What do my other two have in common? A -3, so take that out. I'm going to have a 3x plus 4. It's exactly what you want to happen. These are going to be the same, so I'm only going to keep one. I'm going to put these two together to make 2x minus 3 times one of my common ones, 3x plus 4. So that's grouping. Box method is where I start with an x. On top I put b, or I put a times c, so that's your 6 times -12. So there's your -72. -1 goes on bottom, so this is a times c. This is your b on bottom. I need to multiply to get -72, add to get -1. We have already figured that out. That's -9 and +8. Then I go over here to this box. And my factors are going to go on the sides. Well, my first term goes in the first box, 6x squared. Last term in the last box, -12. And these two that I came out with my x go in here, -9x and +8x. And then I just have to fill in the outsides. What am I going to multiply together that's going to give me 6x squared? Well, that's a 2x and a 3x. Well, in order for this to work out, my 3x has to go here and my 2x has to go here. And then I think, okay, 3x times what gives me -9x? Well, that's -3. And then 2x times what gives me 8x? Well, that's going to be 4. And then you want to check. Does -3 times 4 give me -12? Yes. So now my factors that come out of this are 2x minus 3 and 3x plus 4. Okay, bottoms up method. First thing I'm going to do is multiply my 6 to my -12. X squared minus x minus 72. Factor it like I would with the coefficient of 1. X and x multiplies to -72, adds to -1, -9, +8. That 6 comes back into play. I take both of these numbers and divide them by 6, and then I reduce. So x minus 3/2 and x plus 4/3. Bottoms up, the name of the game. My denominator becomes my leading coefficient. So 2x minus 3 and 3x plus 4. So now you've got 3 different ways to factor a trinomial with a leading coefficient not equal to 1. You pick your method and you stick to it. Alright, try factoring this on your own using whatever method you want. I'm going to show you with all 3 methods. My first method is just by grouping. I've got to take the 2, multiply that by the 35. I'm looking for factors of 70. That add up to -19. So let's see, 70 would be 2 and 35, 4 doesn't work. What is it divided by 5? 5 and 14. 5 and 14 work. They're both going to have to be negative in order to get a -19 and a +70. So I've regrouped this into 2x squared minus 5x minus 14x plus 35. Okay, group. In the first group, I'm going to take out an x. I'm going to have a 2x minus 5 left over. Second group, I can take out a negative 7. Anytime this term right here is negative, you do want to factor out a negative. So take out a negative 7. I'm going to have x minus 5, or I'm sorry, 2x minus 5 left over. Bring my outsides together. X minus 7 times 2x minus 5 equals 0. All right. Second way, using x in box. I would put my 70 on the top, my 2 times 35, my negative 19 on bottom. I do know that this is going to be negative 5 and negative 14, so I go to my box. My first term is 2x squared, my last term is 35, negative 5x, negative 14x. Now I'm filling in the blanks. How do I get 2x squared? Well, I'm going to have 2x and x. 2x times negative 7 gives me 14x. X times negative 5 gives me 5x. This does check. So my factors are 2x minus 5 and x minus 7. Bottoms up method. I'm going to multiply the 2 over. X squared minus 19x plus 70, plus 70, that's right, equals 0. Factors is going to be x minus 5, x minus 14 equals 0. Bring in that 2 that I took out at the beginning. So this is x minus 5 halves, x minus 7. I only have 1 to bottoms up. So my factors are 2x minus 5, x minus 7 equals 0. Now here's what we haven't had into play yet. This equals 0. Once I have two factors equal to 0, set my two factors equal to 0 and solve them. 2x minus 5 equals 0 means that x will equal, add my 5, divide by 2, 5 halves. X minus 7 equals 0 means that x will equal 7. So there's two solutions to the quadratic. Your sum and difference of cubes. When you have perfect cubes being added or subtracted, they follow such patterns. Factoring. What am I cubing to get 27x cubed? Well, I have to cube a 3 to get 27 and an x to get x cubed. What am I cubing to get 8? A 2. This is a sum, so I'm using that pattern. 3x plus 2 times, when I square 3x, make sure you square the 3 as well, 9x squared minus 6x plus 4. If you are giving a problem with 4 terms, you have to factor it by grouping. First two together, last two together. What do they have in common? X squared. Left over, I'm going to have an x minus 3. What do these two have in common? A 5. X minus 3 left over. Bring your outsides together. X squared plus 5 times x minus 3. Okay, at the end of your notes, I would like you to factor these 10 problems and come prepared to check your work when you come to class.